Hey, I'm Phil McCaffrey, and this is 8:30 Prep. Let me get my YouTube studio up so I can get some comments from people. I was hoping my peeps would see my Facebook page and click on it for me and make some comments. So let me pop up my comments. I'm sorry I wasn't ready. And then we'll go to the board. All right. Let's go over to the board here. Teo, what am I doing? All right. It's 8:30 Prep. It's Shark Week, which means it's geometry on the ACT. Today we're talking about circles, arcs, and sectors. Gavin, are you here? I got a special slide for you. I hope you watched the other video. My cousin Martin said he would click on it. Are you there, Martin? So I would love to see some of my friends just help me out, pump up my numbers on YouTube. So, what's a circle? Let's talk about the parts of a circle. So, the parts of a circle are very simple. A circle is the set of all points that are equal distant from a center point, which is called the origin, typically labeled O on any standardized test. I've got everything out of place here. This is too far.
Got Gavin in there.
Gavin's in there?
Hello.
I am here, Gavin. Well, you are going to get the equation. Did you watch the video that I sent you? All right. Most important thing to know about a circle is to go from the center to the edge, and that is a radius. Almost everything on standardized test is center radius. So that's Phil saying center radius. Always put your pencil on the center and go to the radius, and that will more than likely get you where you need to go. There are other parts of a circle. A radius is half of a diameter. A diameter is a line through the origin, a line segment through the origin going to parts of the circle. There is another part of the circle which is a line segment from one part of a circle to another, and this is called a chord. So you'll have to know that one, interestingly enough, chord. And if you have a line segment that goes from a part of the circle through the circle out, it is called a secant. And yes, this has something to do with trigonometry, but I'm not going to teach that. Now, one thing I do want you to know 100% is that if you have a line segment from the diameters that touch the circle, it always forms a right angle. This is important. It comes up. So let's take a look at some other things. The two most important formulas, you should know this. This is basic elementary school math. Yeah, you haven't watched the video yet, Gavin. Come on, Gavin. You've got plenty of time over Easter. You're at home. You have nothing to do. All right, but the two most important ones are circumference and area. And the circumference is 2 pi r or pi d. Pi is the ratio of circumference to diameter. So if we solved for pi, we would get pi equals circumference divided by diameter. Area is pi r squared. The most important thing to know is to not mess these two up, and I will show you on problems to not confuse them. They both have a pi, they both have an r, and they both have a 2. One is a coefficient, one is an exponent, so don't screw it up. These are the important formulas of a circle. Another word I want you to know is tangent to a circle. If a line is tangent to a circle, this is not the tangent of opposite over adjacent. It means that the line touches the circle at exactly one point. And if I draw a line here, this radius, let's make this a radius, the tangent line to the radius that it touches forms a 90-degree angle. This is a famous old SAT problem, standardized test, where we would go out here and form a 30, 60, 90 triangle. In my first not my first office, my second office in Swickley, I used to leave this picture up on the whiteboard and ask every student to solve it. And sure enough, it showed up on the SAT, whereas this is a radius, and this is a radius, and this is a radius. And if it's a 30, 60, 90 triangle, this length here is also a radius. So we would get this part as radius square root of 3. It's such a popular problem for standardized tests that my teacher exam to be a math teacher had this problem on it, only the triangle was flipped to the other side and the radius was 7, and so the length of the hypotenuse was 14, and that was the answer to the question. I still remember it. I love it that I got to do a really hard math problem in seconds because I do test prep. Jumping into problems. Let's do some circle problems, and then we're going to get into sectors and arcs. So this says the Pep Squad plans to make a circular sign in the shape of a basketball to hang on a wall for the game. The circle will have a radius of 4 feet. Phil's rule number 1, read with your pencil, underline key math words, write an equation. What is the closest to the perimeter? The perimeter is pi r squared. See what I did? Pi r squared. It's not pi r squared, it's 2 pi r. It is 4 times 2 times pi. And when it says the closest to it, one of the things that you can do, if you're a smart ass like me, is just to say that this is 8 times 3, or it's going to be close to 24, which the answer is 25. You can approximate pi at 3, do it very quickly, do integer math. If you want to score high on the ACT and the SAT, practice your integer arithmetic, practice it so that you're very quick with it. Your times tables, adding and subtracting. And if you notice, I do that wrong a lot. I love this question. The diameter of a circle is 36 feet, as shown in the figure below. What's that?
Yards. You said feet.
Feet. Oh, 36 yards. Reading too quickly. RTFQ. There we go. Our famous saying. David, are you there? I have to text my partner so I could click on and pump up on YouTube numbers. 36 yards as shown. What is the circumference in yards? So make sure that you have yards and feet. And we know that pi d is the circumference, so it's just 36 pi. So this entire problem would have taken me under 5 seconds because I've practiced circles. What is the circumference in centimeters of a circle with a radius of 6 pi? Now, notice one thing here. Pi r squared would be equal to 36 pi. Big frowny face. Wrong answer. It is 2 pi r, or 12 pi. So the answer is 12 pi, but it has the area on it. I wanted to show you that all the time on there. What is the area of this actual circle with a radius of 6? 36. And we'll see another one. I think the next one coming up has all kinds. Nope, this doesn't. What's this one? A circle in the standard xy plane has its center at -2, 4 and passes through 3, 16. Oh yeah, I didn't practice this one because I wanted to play it out and show you how to do this one. So let's write a xy plane, and let's go to -2, +4. So -2, 4. And then we're going to go to +3 up to 16. So 2 to 3 gives me an x change of 5 units. And 4 to, that's a 16, isn't it? 16. And a 16. 16 candles. That's not 5 and 16. That looks like an isosceles triangle. But the reason I wanted to do this one is because I was right. It does turn out to be a triangle problem with a Pythagorean triplet, the 5, 12, 13. It wants to know the area in square coordinate units of this circle, 13 squared. If you did my formulas of ACT, which is a video I've got on here, know your squares. Know 13 squared is 169. The circle shown below has a diameter of 6. What is the area? Okay, here we go. It's a 41. This is a really easy problem. Pi r squared. So always do what Phil said, which is underline diameter and write an equation. My rules are read with your pencil, underline keywords, write an equation, draw a picture, and estimate. So the diameter is 6, so the radius is 3. Let's see how many possible wrong answers we can have. Is there a 36 pi, which is the diameter squared? Yep. Is there a 12 pi, which is 2 pi d, really a screwed up equation? Yes. Is there a 9 pi, which is pi r squared? That is r. 3 squared is 9. That's our correct answer. And what do we have here is pi d, which is our circumference, or 2 pi r. 3 times 2 is 6. And then 3 pi, which is pi r. So look what they have here. They have pi r. They have 2 pi r, or pi d. They have pi r squared. They have pi 2 pi d and pi d squared. This is I'm gonna save this bad boy. I'm gonna put this up and put it on my new blog and newsletter, Fill in the Bubble, which I'll introduce here shortly as I get my new website up and running. This is really beautiful. This is probably the most well-designed wrong answers I've ever seen. All right, I love this question because they give you a formula, an equation to work with for any circle with 2 secants. I picked it because it had the word secant. With 2 secants drawn from P to the circle as shown below, the lengths of the segments of the circle are determined by the equation A times the quantity A plus B is equal to C times the quantity C plus D. They give you the equation. This is a plug and chug. So they give you 3 of the 4 numbers that you need. So it is 4 times 4 plus 11, which is 15, is equal to 5 times 5 plus x, which is d to e. And so let's solve this bad boy. 4 times 15 is 60. Let's even do Phil's math way faster, which is divide by 5. And we get, this cancels to 3. We get 12 is equal to 5 plus x. Write out your equations and try to see if you can divide out quickly. Instead of multiplying 4 times 15 and getting 16 and dividing by 5 and getting 12, just divide by 5. See how fast you can work a problem. And then 12 minus 5 is 7. This is a really cool problem. It's unique on the ACT. It's just some algebra with a circle and the word secant, and it was all put together. I had to split the question apart because it would have been too small and nasty on there. But I really do like that problem. Whoever wrote that, whatever professor they hired to write that, is a really, really good test writer. All right, arcs and circles. An arc is a part of the circumference of the circle. The sector is the piece of pizza. So if we have the center O and 2 points A, B, such that we now have an angle AOB, or usually called theta or x, the arc length from A to B is a piece of the circumference. It's also the arc angle. So all arc angles are in proportion to each other because all circles are in proportion. So the most important thing you need to know about arcs and sectors is that there is a proportion. And the proportion works like this, that theta over 360 is the part over the whole. They almost always give you the angle, so it's angle divided by 360. And that equals arc length, AB. I'm going to draw that in red because I drew it in red. The symbol arc, a curve over A to B, means arc length. and that's divided by 2 pi r, or pi d, which is the whole circumference. And then it's also equal to, and I'm going to shade this in green and draw a piece of a wedge like an old-fashioned, anybody ever play the game Trivial Pursuit where you had wedges? Did you ever play that game, Teo? Trivial Pursuit, where you had wedges in a little circle and you had to fill in your circle? Yeah, well, there's not a math symbol of sectors that I know. If anybody knows that, email me at phil@3rprep and let me know. And this is over pi r squared. Take this bad boy to the bank. It shows up all the time. It's not 100% of the time. The old SAT really, really loved this. And of course, I'm always talking about the old SAT as if I was missing the old days before 2016 like an old man. Let's do some sector problems. The ACT loves circle graphs. They love circle graphs. And it says Antoine drew the circle graph below, describing his time spent at school for one day. His teacher said that the number of hours listed were correct, but the central angle measures for the sector was not correct. What should be the central angle for the core subjects? The core subjects is 4, and then we have 4 plus 3 plus 1, which gives me 9. 4/9 is equal to, this is one where theta is the unknown, is equal to theta over 360. So we will then cross multiply. So we have 4 times 360 over 9. 9 goes into 36 4 times. So we get 4 times 40, which equals 160. Answer choice H. So it's about half. The one thing is about half of a circle is 180 degrees. So the only two answers that made any sense at all is 160 or 200, which is a little less or a little more than half. The other ones don't make any sense at all. So remember to estimate and eliminate wrong answers. Phil's rules: read with your pencil, write an equation, do math like you're in 7th grade, draw a picture, and use the answers. Estimate, plug in numbers, and back solve. I love this wristwatch one. This one's pretty cool. On a wristwatch shown below, the hour hand rotates 30 degrees because there's 12 hours, base 12, in the system of our time, and there's 360 degrees. 360 divided by 12 is 30. The minute hand rotates 360 degrees per hour. How many degrees will the hour hand rotate from 6 p.m. to 6:42? So it's going to go 42 minutes out of 60 times 30 degrees. When you write an equation, the one thing that you can do is I can do math faster with an equation than most of my students can pick up their calculator and turn it on, because 30 goes into 62 times, and 1/2 of 42 is 21. I could have solved this problem in about 15 seconds if I set up the equation correctly, which would have taken about 15 seconds to set up. So this is a 23. It's about a 20 to 30 second question if you practice, but it's a really, really nice ARC question. Here's one. The diameter of this pool cover is, I believe, 24 feet, so the radius is 12. I didn't copy the part. This is one of those questions that has a diagram and then 3 other questions associated with it. So if I remember quite correctly, it's 12. It says a plastic cover is made for the pool. The cover will rest on top of the pool and will include a wedge-shaped flap formed in a 45-degree angle at the center shown below. A zipper will go on one side of the wedge-shaped flap. So I've got a zipper here. So I've got radius. So my answer has to be 12 plus something. And 12 plus a piece of the circle. Let's estimate right now. If this is 12 plus this piece, is it going to be 57? That's just insane. Is that the circumference of this? 2 pi r. What's 3 times 24? No, 72. But it's still way too big. 57 is ridiculous. I love to look at the answer choices and eliminate them. So what do I have here? I have 45 out of 360 is my piece. That's my fraction, and 45 goes into 360. Everybody should actually know this one because 45 is half of 90. So it is 1/4 of a circle is 90. This is 1/8 of the circle. So 1/8 of the circumference, which is 24 pi. They gave the radius. I'm going to have to go back and look at this, see if it's 12 or 6. Uh-oh. Rhubarb. My mom said I made pie. Thanks, Peyton. Pie is delicious. 3 times pi. So if this is 3 times pi, which is 3 plus 12, 9 plus 12, 21. Yeah, this one is 22 feet. I was right. Good. Whew. I should have written 12 feet down on that one. All right, here we go. Ready? A poll of 200 registered voters was taken. All 200 votes are for one of 4 candidates shown below. If the information in the table was converted to a circle graph, pie chart. I love that they put circle graph and then pie chart in parentheses. The ACT loves circle graphs, otherwise known as pie charts. Then the central angle of the sector for Gomez would be what? So the part is 40. The whole is 200. 4 goes into 20, 1/5. This is 1/5 of 360 degrees. Folks, 360 degrees divided by 5. Oops, clear my calculator. 360 degrees divided by 5 is equal to 72. Okay, can you do me a favor? You want a high score? Memorize this stupid fraction. I have seen 1/5 of 360 appear more on the SAT and the ACT than any other fraction. The other ones they like is 45 degrees, 1/8 of 360, 90 degrees, 1/4 of 360. And here we go, Gavin. I'm finishing up. Pie is delicious. Rhubarb pie. My wife also made a salad from kale that wintered over. So if I have a circle in the XY coordinate plane that has the coordinates of HK at the center, then the equation of the circle is x minus h squared plus y minus k squared equals r squared. If it was based at the center, it would just be x squared plus y squared equals the radius squared, which looks a lot like the Pythagorean theorem, because it is. Trigonometry is actually called triangleonometry, and that is splitting triangles into the pieces of splitting circles into pieces of triangles and doing the whole world as circles split into triangles. And that's the equation of a circle. This is 8:30 prep. Not bad, 8:53. What's that? Meme of the week. My meme today, a shout out to Dr. Dave from North Hills who sent me the Obi-Wan Kenobi C. That is an answer choice I haven't heard in a long time. Haven't picked in a long time. Thanks, Dave, for that. Do the meme of the week. Send me a meme. Somebody send me a meme. I've got Starbucks gift cards to send out to anybody that sends me a meme. I was watching myself last night. I was rubbing my hands. It's like I'm evil. Please send me a meme of the week. I'll see you tomorrow night for solids and multiple figures on geometry on Monday, Thursday, Holy Thursday. Hope you have a happy Easter if you don't tune in. And watch the video. Give it a like, subscribe. I appreciate it. We'll see you tomorrow night.